Welcome to log blog number 7. In this video, I'm going to prove that the log of c to the base b is equal to the log of c to any base divided by the log of b to any base. And secondly, that the log of b to the base a is the log of a to the base b to the negative 1, which of course means 1 over log of a to the base b. So these logs are reciprocals. But first, today's anagram, gentlemen, you know the drill. And before we prove those two things, I just want to remember that in the last video, we solved the equation 5 to the x equals 92 by using the law of a power, and we ended up with x equals the log of 92 divided by the log of 5 using log to the base 10, and that was about, what was it again? Yeah, about 2.8. What I want to point out is that this is not the same as the log of 92 over 5. Don't make that mistake. Check on a calculator, it's not the same thing. So if you're rushing and you skip a step or two, you might put this, but it's not equal to that. Okay, let's do the proofs. Number 1, let x be the left-hand side, the log of c to the base b. So that's the same as saying that b to the x equals c. X is the exponent to which the base b must be raised to give the number c. Now let's take the log of both sides. So we get the log to any base of b to the x equals the log to the same base of c. And then of course we can use the law for the log of a power to get x log b to the base a equals the log of c to the base a. So x is equal to this log divided by that log, which is the right-hand side. And what was x? Well, x is up here, so that's the left-hand side. So we've proven it. QED, big fat check mark, or better yet, smiley face. So if you need to calculate, for example, the log of, let's say, 160 to the base 7, which most calculators can't do because they don't have more than 2 log keys, the log to the base 10 and the log to the base e. Remember, e is Euler's number 2.718281828, and then just when you think it's going to repeat, it doesn't. It's a number like pi, irrational number. This is equal to the log to any base of 160 divided by the log to any base of 7. I'm going to use base 10, or if you want, you could use the natural log, the only other logarithm key that most calculators have. And that works out to be about 2.6. You can check that out for yourself. Okay, the second proof. Okay, let x be the left-hand side. So that's log of b to the base a. And let y be the other log, log of a to the base b. So this implies that a to the x equals b, because x is the exponent to which the base must be raised to give that number. And this implies that b to the y equals a, because y is the exponent to which the base must be raised to give that number. So let's substitute this for a in this equation, and I will get b to the y all to the x equals b. The left-hand side to be written as b to the yx, or b to the xy. That's equal to b. Of course, this is b to the 1. If you want to put a 1 there, put a 1 there. See if I care. Now you see it, now you don't, because we don't normally put it. But because that's a 1, that says that therefore yx, or xy if you prefer, must equal 1. So x equals 1 over y. Don't forget, x was this, y was that. So again, we've proven it. QED, big fat check mark, or better yet, smiley face. Okay, to finish up, what is the anagram for gentleman? Well, I'll give you a hint. It is some kind of a man, and it is an elegant man, without the an. Match up the letters and you will see. Okay, stay tuned. We've got more to cover regarding logarithms. All the best.